Hello, this is an Onan 6.5 NH. I refurbished this unit going back several months ago. As you can see, I'm using a gasoline only carburetor. You can tell by the choke and well, the fuel line, which you really can't see on this end. What I really wanted to do is run other fuels such as propane and natural gas. They do make kits for that, but they're rather expensive. So what I did, being I like to tinker around with things, I made a device that installs on the top of the carburetor. This guy right here. Very simple device. Nothing more than a demand regulator, a valve, and what we call a spud, which is a tube that goes into the carburetor into a specific location into the Venturi. The purpose of this video is to run some tests. There was concern from a stack member that using vapor, it may cause excessive heat problems with the motor. So what I'm going to do is record all my temperatures for the left cylinder and right cylinder at various loads and see how they measure up with gasoline, because I'm going to repeat the test with gasoline. I did the same exact test with a 4.0 BFA that I have using the same exact device because it transports easily between gensets. If you have this type of air duct work, all you need to do is just unbolt it using these two thumb nuts, and I could use it on any genset. Doesn't matter what carburetor. Well, actually I used the Nicky and the Walbro carb with excellent results. I did run it before on this genset, but I didn't take any kind of test measurements other than output, and I was able to achieve full output, full rated output, 6.5 kilowatts using, again, this device and on propane. But we're going to do some in-depth tests using the infrared sensor right there and doing some recording and see what we have and compare it to gasoline. So this is basically my setup. Here's our generator. There's my 3 tanks of propane. My Johnny kilowatt meter right here. You'll see this in action, but basically it's going to give me the hertz and all kinds of information on the on one leg and then on the other leg right here. We got our infrared thermometer right here. We're all set up. This is for one leg, that's for the other, 30 amps on each, and that's really about it. Alright, here we are. We got the Onan 6.5 NH started on propane. We're ready to start testing. We don't have any load yet on the generator. It's just a small load. That's probably because of these guys right here. They're off, but you know, it's a little bit of power drain. So what do we have here? We currently have 2 heaters on each leg. I'm assuming that these are you know, 1500, maybe 1200 watt heaters. This should probably load down the system pretty good. I got more heaters in the background. But anyway, we're going to start recording our measurements from this box right here. As you can see, our hertz. We have our voltage. We have our amperage draw. We have our watts. Same thing for here too. One is one leg, the other is the other leg. What else can I say? Let's start testing. Right now we're running about 3,000 watts the past 5 minutes or so. You can see we got about a little over 1,500 watts on each leg. The average temperature between the left and right cylinders at the exhaust flange mounting bolt is about 180 degrees Celsius. This is pretty good so far. Everything's running nice and stable. Right now I only got 2 of the heaters turned on, one on each leg, because I'm trying to balance things out. Let's kick up the juice a little bit here. Okay, we're running full steam right now. We got pretty much all these heaters going, except for this piece of crap. It keeps cutting out on me. Anyway, what do we got here? This thing's chugging along pretty good. Well, as you can see, we're pretty much at max. This 6,500 kilowatt generator, we're just slightly over that. Pretty much almost 30 amps on each leg. 58.3 hertz, which is pretty acceptable. What I have as far as temperature on one side of the cylinder by the exhaust flange manifold, 225 degrees Celsius, the other 222 Celsius. So far pretty good. This thing seems to be handling it pretty good. It's been running now for about 3 or 4 minutes. Got another couple heating devices in the back, so I'll hook them up. I think one of my devices probably just cut back. Yeah, you can see up here that dropped down. So I think I got these heating units too close to each other. probably reaching temperature and cutting back like they should. So maybe I'll have to spread them out a bit. Anyway, looks like we're doing good with the testing. I'm going to let this thing run a little bit longer, plug in a couple more devices and see if I could get this thing going. All right. The device that cut out came back in, so we're cooking now. All right, let me hook up a couple more heaters. Okay, I'm letting this genset cool down. We did all our testing. I'm going to input the results into the spreadsheet on the computer. Temperature-wise, voltage first, and all that. Right now, I just got a very small load on the genset, running propane. You know, I guess 2 heaters going. One thing I forgot to do, I forgot to disconnect the fuel pump, and I noticed it was tapping pretty hard towards the end of the test. Obviously, no fuel in it. For a minute, I thought I threw a rod or something, because I was loading this genset well above maximum rating with all these heaters. I have no mercy whatsoever. I was tripping the breakers on the genset. I was tripping the breaker over here. One leg off, one leg on, all legs off. Just reset them and just keep going at it. Anyway, I got concerned about the hard tapping. Little did I realize it was just the electric fuel pump, so I pulled that wire off. Lesson learned. I hope I didn't do any damage to it, but you know, obviously it's dry. So this is my test for propane with this little device that I made. Really haven't given it a name yet. Got some light effects going on in the background. I guess it'll look a little bit better at nighttime, maybe not at all. But anyway, this is the mess that I got. So the next phase is to test this thing on gasoline, which of course I know it's going to run, but I want to check the temperatures of the cylinders at basically the same power draw. So that's pretty much it for today. Check back with me later. Folks, it's a new day and a new test. Today we're going to be measuring the exhaust temperatures at various loads using gasoline. We did the propane yesterday and the results were posted. What I've done between yesterday and today, I hooked up my gas fuel line, and that's really about it. Now what I need to do, I need to remove my little gizmo thing here. So let's do that. If you notice that the choke is fully opened, okay, the device actually opens it automatically for you once you insert it. So what I want to do is remove this guy. So basically what I'm doing right now is just undoing these thumb bolts right here. Kind of long, so it takes a little while. I'm also trying to juggle this phone at the same time. And let's get this last one over here, because we want to restore this to its normal operation using gasoline. Actually, this thing could remain on here if the engine was warm and I decided to run gasoline. The only thing that stops us is the choke. Okay, it's fully open. So if the machine was fully warmed up, well, then there wouldn't be any problem. Okay, watch the movement of the choke thing here. You all know what this means. Okay, as I lift it off, the choke now closes. The engine's cold, of course, and what I'm doing, I'm just placing this device over here. So technically, right now, it's back to its normal configuration, other than I need to put the cap on. I do have my original cap right here, and I'm going to put that on, and it's just a matter of putting these bolts in. Excuse me. Then we're all ready to start this guy up and run on gasoline. Okay, so let me do that. Again, I apologize. It's kind of hard to hold a cell phone taking the movie while getting these guys in. That's really about it. It's a reverse procedure if I decide to run gas again. Alright, I would just take this guy right here, take off this cap, put the device on top, bolt it in, boom, you're ready to go. The choke automatically will open for you because the spud, which is that silver thing at the end, will automatically push the choke open. It's designed to do that. One thing you need to do, though, however, if you're running on vapor, is to remember to disconnect the electric fuel pump. Otherwise, that thing is going to continuously go. And if you don't have any line hooked up for gasoline, it's going to run dry. It's going to click like hell. All right, so let me get this thing going, and we'll be back in a moment. Well, I just conducted my first test, basically just getting this thing running. No load, no nothing, other than my annoying emergency light. I took the temperatures of both the left and right cylinder, some other vital information. I was really surprised because I'm going to tell you why. Okay, originally yesterday, between the left and right cylinder, I was about 149 degrees Celsius, okay, 150. Voltage about 132, hertz about 62.8. I expect the gasoline to run cooler. It's actually running hotter. Okay, as you can see, I got 167 degrees Celsius on one cylinder, 169 on the other. My voltage is lower as well. Okay, right now you can see it's about 128, 129 volts on the box, but there's a big difference in temperature. I don't know why gasoline is hotter than vapor. My understanding is that vapor would have been hotter than gasoline. So my device, I guess, is running cooler, at least initially. So what I'm going to start doing, I'm going to start loading this gen set up. Try to get approximately the same amperage draw on gasoline as I did with propane, and let's see what our results are. In the meantime, enjoy the annoying lights. By the way, the propane bottles are not hooked up. We're running strictly gasoline right now. This is the gizmo thing that we took off. Okay, anyway, let's get testing. Alright, I just ran the test. I'm running 1500 watts approximately on each leg. I took the measurements as far as the temperature from the left and right cylinder, amperage, the whole 9 yards. Once again, I'm showing higher temperatures running on gasoline than I did on propane. Just doesn't make sense. Again, I thought propane, as well as natural gas, is going to cause higher operating temperatures, but that's not the case. So I'm a little baffled here. Okay, just to show you what I got. All right, for example, on propane. All right, let me get this right here. On propane at about 12.7, 12.5 watts, which is about, or excuse me, amps, which is about 1500 watts. I'm showing temperatures at 179 and 181. Whereas with the approximate same draw on gasoline, I'm showing higher temperatures, 194, 199. You hear the engine changing speed. That's because one of my heaters is kicking in and out. So, I don't know. But anyway, I was able to do the recording when both devices were kicked in. You can see right here, this one right here on one leg, the heater did kick out. This one's still in here. Okay, it'll kick back on. Anyway, just kicked back on. So I got one heater that likes to cut in and out. All right, anyway. I'm going to up the draw, and let's see if consistently I see higher temperatures on gasoline than on propane. By the way, this carburetor is not modified. Okay, this is stock carburetor all the way. No modifications whatsoever. So, in its native mode, if you want to call it that on gasoline, it should be running optimum. Whereas when I stick this thing on, my little homemade device, apparently it's making the engine run cooler for the same equal draw of load. Alright, let me get back to setting up for my next test. Once again, here's my annoying lights. Okay, it's kind of getting me dizzy. Alright, we'll be back. Okay, we're really cooking here now. I got the thing at full load. I got, well, not all these heaters running, but most of them, whatever. I had to spread them out because they're kicking off. It's getting hot in this garage. Anyway, I'm up to the 7,000 watt level. But to compare what I got going here, looking at my last test on propane, I was doing about 29, 30 amps per leg. The top temperatures were 225 and 222 degrees Celsius at about 111, 112 volts AC. Comparing with gasoline, okay, with the same heaters, running slightly higher amperage. The temperatures are very comparable now, okay? Apparently now gasoline seems to be running just a little bit cooler, about the same, okay? Looking at the last line here on propane to the last line here on gasoline. Voltages are a little higher on gasoline, of course wattages as well. So basically, I guess, as expected, gasoline's going to surpass propane, especially at the higher end. So you can see where the propane's starting to drop off, I guess you could say. You can see the hertz on propane was 58.8 as opposed to 60.3. Actually, my gauge is wavering between 59.9. So anyway, I'm running 7,000 watts right now in gasoline. Pretty comparable, I guess, to propane as far as the temperatures and all that. So on lower amperages, lower draw, looks like my propane device is actually running more efficient, if you want to call it that. Temperatures are better as far as being cooler, and it seems to run a little bit better overall. So anyway, I think this concludes the test using gasoline and comparing it now to at least propane. And I guess what we have to do now is get this thing on natural gas. I don't really expect great results on natural gas as far as achieving overall wattage, but we'll see. So that'll be the next test that I'll do some other day. In the meantime, enjoy the annoying light.